Alrighty. All right. Hi, everyone. My name is Malik Bayari. I am with Robojackets, and today we're going to learn about how to CAD with Inventor. Um, so what is CAD? So CAD is computer-aided design. Some of you may be familiar with it, some of you may not be familiar, but we basically use it to create 3D modelings, and it allows for a cheap iteration of designs, which basically just means if there's something you want to change quickly, you can in the Inventor app with no cost to you. It's a close enough prediction to your final product, which is really nice for robotics competitions, and it doesn't replace real visualizations. Obviously, if you're going to put something into CAD, sketch it out first. And if there are any questions during this presentation, feel free to stop me, hosts, or panelists, and I'll answer them, or you guys can answer them. Yeah, so some CAD terminology that you'll have to know when starting to CAD is you'll need to know what a sketch is. So a sketch is the lowest level of organization. You always start your models with a 2D sketch, and you can extend that later into a feature or a part. So a feature is a 3D aspect of a part. Usually you'll extrude, or it's kind of a step up from a sketch. So you're taking your sketch and you're making it more three-dimensional, more lifelike. A part will consist of multiple sketches and features. So it's kind of an amalgamation of one design. And your assembly is an amalgamation of your parts. So it's all your parts in one area, and that's what your robot will look like at the end. You'll kind of design all of your mechanisms or smaller assemblies separately, and then you can add them all into one area to represent what your robot will look like when you're done with that. So here's a picture of a sketch. Really just represents a 2D plane. You can start sketching on the X, Y, Y, Z, or X, Z axis. It really just depends on how you want that part to look in three-dimensional space. So when you're drawing on a sketch, you need to be specific. This specificity is called constraining. So, computers aren't that smart. They need you to kind of tell it what to do, when to do it. So when you're making even just a simple rectangle, you have to give it dimensions. Is it a 3 by 10 or a 10 by 3? Those are two very different kind of shapes. That was a bad example, but you have to constrain it and give it specificity and details. So in Inventor specifically, this image is a kind of a bad one, but it'll let you know when your sketch isn't defined. So in Inventor, when you make a rectangle, this purple part that is here, it'll be black. So a black line means that the locations are known, it's defined, and it knows where it's sitting in space. A purple line means that it's not known, it's undefined. That's what this green line used to be. So just look out for those lines, black and purple. You want your sketch to kind of completely be all in black before you move on to the next step. Here's some sketch constraints. The main one that you'll need to know for FTC is this, or FRC is this dimension right here. There are multiple constraining methods in Inventor. It'll help you go from a simple geometry to a very complex one. And while you're doing these constraints, you need to ask yourself, what will happen if you move the line? Because a lot of the time, you'll get like an error when you're constraining stuff, and your CAD will break, and that's not very fun. But we have tools in Inventor to help us know when something isn't defined really well or when something is potentially going to be broken. But these tools right here are very easy to learn, easy to use when you're doing your CAD. Most of the time you can hover over them, and I can show an example in actual Inventor later if needed, but you can hover over them and it'll tell you what they do. Okay, so sketch constraints continued. Some other frequently used constraints that we use are the coincident, parallel. So coincident is two parts next to each other when you want to get them close together and touching. Parallel, obviously, you need two sketches or whatever it may be to be parallel from each other. Tangent is referring to that 90-degree kind of, usually we set like a line offset to a circle. That's tangent. Concentric, a circle within a circle, is a great example of that. Horizontal/vertical is a really great tool to use whenever you're starting to make your sketches, rather than messing around with it while you're sketching and making it a perfect 90-degree line or whatever. You can draw the line and then have Inventor fix it for you. Symmetric, when you want your parts to be the same, I use symmetric a lot with, or not the same, but whenever you're like mirroring off things. The equal constraint is really nice to use whenever you want things to look the same. I use that a lot for hole sizes. So if you're trying to make like holes in your part, if you're 3D printing, it's really great to use that constraint if you want them to be the same size. And the fixed constraint is super nice to kind of ground a sketch so that whenever you add stuff to it or move it around, it won't move, it'll stay in one place. So, like I said earlier, there are many tools in Inventor to help us know when your CAD is broken or won't constrain properly. So, usually when something can't or isn't constraining the way you want it to and you don't know why, you can go to this show all degrees of freedom. Usually it'll be like a right click and this whole toolbar will kind of pop up. So red arrows will indicate where lines can move. So that will be your best friend when you're CADing. It's really helpful to know what's constrained and what's not constrained. So, like I said earlier, parts is the step up from a sketch. So a part is just a collection of features. All the stuff that I mentioned before was like your features. These files will have an IPT ending, and yeah, as seen below, this is kind of like how we get to it. So you go from a sketch to a feature to a part. Okay, features. So these define the 3D representation of your sketch. So these help it go from a simple sketch to a complex geometry. You can extrude, which is basically if you have like a little square, if you drew a square, you can extrude it and make it a cube. You can revolve, which is almost the same thing as extruding, but instead it's rotating around an axis. A hole tool is really great for screw holes. So if you're designing a part where you're going to be kind of drilling holes into it, using this tool is really helpful because it can give you a lot of different sizes and depths without you having to mess with it yourself. And then the last feature is the sweep and loft feature. Those are the two right up here. We don't use them that often. They're pretty uncommon unless you're using them for very complex and specific geometries like piping or something like that, but we don't really use them in FTC. Not sure about FRC, but I highly doubt it too. So here's a little video of extruding. Hopefully this looks good. Oh, no. Okay. Yeah, it works. So yeah, that's what an extrude looks like. Here's what a revolve, when you revolve something, this is what this will look like. See that they picked an axis here and then it became a part. This is the hole tool. You'll have to kind of identify where the hole is going to be using the point tool in Inventor. And then you can just click the hole feature and click that point and it'll make a hole for you. Yeah, okay, so some more features that we love to use are shells, fillet and chamfers. The hole tool, I've already mentioned that. We love using work planes, projecting geometry, and mirrors and patterns. So what's a shell? A shell is basically a tool that you can use to hollow out the inside of a solid body at a uniform thickness. These are fantastic for 3D printing parts. When you're 3D printing objects, it's really not that great to print it with a full, just everything inside of it, because that takes a lot of filament and a lot of time. So it's really great to shell out your 3D parts if you can. There are many different settings for shells. You can set it to multiple thicknesses, and you can make things like Legos, hollow spheres, or like bins. Here's a video. I think I have to click on it. Oh, okay. Never mind. So I don't think the videos will work, but this video was just a hollowed out shell of a video of just me like showing you guys how to use the shell tool. As you can see, this half section view kind of shows you that it's hollowed out. And if need be, I'll like show you guys how to do that in Inventor when I pull that up at the end. Fillets and chamfers are another tool that we really, really like to use. So fillets are these little rounded edges here. These are really nice to cut away some corners. If you're machining anything, these are also really nice when you're machining. They also just look prettier. A chamfer is an angled edge. And so, yeah. The hole tool. As I mentioned this before, we use these a lot when CADing. In Robojackets as well, we use these all the time. I use the hole tool like no other. It's so much faster than making circle extrusions, and you can really specify all of your information about that hole in there, such as what bit you're going to use and how the depth of it. So they're really helpful. I think that was a video of me using the hole tool. The videos don't work right now. My apologies, but basically you would kind of use the point tool, and then select the hole tool. Next is work planes. So work planes are kind of a little tricky sometimes. Work planes are when you can create a plane and offset it to a certain distance from one of the main 3 planes. You can angle them off of existing edges in your parts, or just off of different surfaces. You really want to use work planes to create or to be able to project geometry onto them. And they're helpful when you want to mirror surfaces over. They will respond to changes made in the original plane, and so you have to be wary of that. Yeah. Dang, I wish these videos worked. Okay. I guess at the end, if anyone wants, I can just like pull up Inventor and I can show you guys how these work because work planes, at least for me, were a little tricky at first, but they are a very helpful tool to use when you're building. Okay, so projecting geometry is also known as reference geometry. This allows you to kind of project a sketch or a feature onto another object. And you can kind of like really make your design super complex. These are really helpful when you're doing a top-down assembly design, which is basically when you start with all of your constraints and you're working towards one product. Reference geometry, just like the work planes, will be updated as the original source is changed. So keep that in mind when you're working with these. Yeah, another video. Mirrors and patterns are the last feature that we like to use a lot. These tools will allow you to quickly mirror sketches or parts over a center line. You can use the construction tool when you're making your axis to mirror over. And they're really helpful when you want multiple different parts that look the same. That way you don't have to sketch and create the same thing over and over and over again. And the pattern tool is the same way. You can kind of create a circular pattern or a rectangular pattern over a degree axis. So if you wanted several dots around a certain part, you can quickly do that. All you have to do is draw the one circle and then use the pattern tool and it'll create like a ring of circles. So I don't know if that makes any sense. I can show it in this video towards the end or in Inventor afterwards. Alrighty, so now that you've learned how to go from a sketch and use your features to make your sketches super complex and then go into a part, it's time to learn about assemblies, which is where everything comes together. These are very important when you're building your robots. You'll need to kind of create like almost a vision of what everything will look like. These are all individual part files that will be added to your assembly and you'll have to constrain them to one another. Yeah, this is an example of an assembly. It's one of our robots. I think it's a battle bot probably, but yeah. So there are multiple different ways to constrain an assembly or constrain your parts to build an assembly. Something I do want to mention real quick is that a lot of the parts in FTC and FRC, when you're downloading like files to put in your assembly, those will in of themselves be assemblies that you'll have to kind of like pull apart and kind of be able to manipulate. So this is a very important concept. You always want to fix the first part by referencing the origin. So when you're starting an assembly, you'll want to bring in the part that you want to build everything off of, and you'll want to kind of ground that to the origin so that it doesn't move around when you start constraining and putting everything in there. So translational and rotational freedom something has to be fixed in order for that to like work. And then when you are constraining things in assemblies, you will find that a lot of constraints will be conflicting. So they'll not agree with each other all the time. You can use this degree of freedom analysis, just like earlier with the sketch, to kind of show you where your constraints are not having fun. Don't suppress them, because you can kind of like shut them out and ignore them. Don't do that, just debug them, because it'll save you a lot of time in the end. Next are movement constraints. These are also super helpful if you want to just see how your part is going to kind of move in real life. you want to fully constrain everything before you even touch these. You want to make sure everything is kind of where it's meant to be before you start going in with the translational and rotational movements of these parts. Yeah. These motion constraints don't account for tolerances. So there will be times where you're messing around with the movement constraint and your part will like go into another part. That happens just because it's CAD, it's a computer. It doesn't know that it can't go that far, but these are kind of helpful to show you how your part should or will move in real life. Next are your angle constraints. These are also pretty helpful if you have a specific angle that you need to achieve between your edges or planar surfaces. As you can see here, these two plates needed to be 125 degrees apart, and using this constraint, we were able to do that pretty easily. Tangent constraint. And you can notice that a lot of the sketch constraints kind of translate into assembly constraints. But yeah, so a tangent constraint, you can constrain like cylindrical surfaces or spheres to other flatter surfaces. So here, this part got the cylindrical part shaded in purple, got constrained to this blue surface. And then later on, you could add a motion constraint to this to make it go up and down this surface. The symmetry constraint positions two parts symmetrically according to a planar surface, obviously. So these just make sure that they are the same distance apart from this work plane in yellow here. And that's really everything that you'll need to know about CAD using Inventor. There's a lot of hotkeys and stuff that I can go over, or you can always look them up. The internet's great, but I just kind of wanted to leave you all with this slide of like what makes a good CAD. And it's the same thing as what makes a good sketch. You want your CAD and your designs to be responsive so that if you need to adjust or make changes, you can do that easily without breaking the whole thing. You want them to be simple. You always want to start off with like simple geometries. If your goal is to create something complex or a mechanism for your robot, you want to be able to break it down into simple geometries of like circles, rectangles, and squares, stuff like that, just so you can easily go back and rework them however you need. And you want them to be robust. So like I said, you don't want it to break when changes are made. And obviously it takes a long time to like get good at CAD. It definitely took me a long time to understand not everything I make in CAD will stay the same way if I change it, but there are a lot of tools in Inventor that can help you out with this. And so yeah, if there are any questions, I'm down to take them, as well as the other panelists. Yeah, are there any thoughts? I can't see the chat screen, so I don't know.
Hey, just so you know, you can share Inventor like how you would share a PowerPoint, so you can show them stuff in Inventor if you want.
Yeah, I'm down to do that. Let's just exit out. Okay. All right.
There you go. Yeah.
Sweet. So here's Inventor. If you've never looked at it before, this is where all of the stuff you work on will kind of be. Working on my own little robot. But yeah, usually you'll just kind of go into here, click new, and then it should open up this little tab. You can just go to create, I think. Okay, it looks a little whack. Okay. And a sketch screen should pop up soon. Yeah. Okay. Hope This is not what I wanted. My bad. Let's not. Okay, just go here. Okay. Was there anything in Inventor that y'all wanted to see? I know the videos like didn't work, so there was anything there that is a little confusing. Or any like specific questions about how to use Inventor for FTC or FRC?
Malik, do you want to make a quick part and then just pop open an assembly and constrain them together?
Sure, we can do that. Okay, so I'll just make a quick little circle. Extrude it.
For those of you who have not messed around with Inventor before, if you noticed, the sketch was still purple, but you are still able to do operations such as extruding or cutting holes, even if the part isn't fully dimensioned. We don't recommend doing this, but for all intensive purposes, this will work for now.
Yeah, no, for sure. Don't do what I'm doing. I'm just kind of like messing around now. So whenever you're kind of creating your assemblies, you'll just have to obviously save your parts, and you'll use this little place button to bring them in. Bring in the other part.
Alex, I believe there's a question in the Q&A. I feel like you might be better suited to answer this one.
Sure, you can answer that.
That was constraining it. Obviously, it's not perfect, but you can see that this bottom surface of the cube is constrained to be on the same level as the surface of this cylinder. Obviously, I can constrain it more probably to make it stay, but that was just using the basic mating constraint. So that's the most basic constraint to use whenever you're just kind of attaching parts to each other. Just gonna quickly show you guys how to use the pattern tool. So go here and make like a little circle. Dimension it as well. 1/4 inch. And then maybe I want it that far away. Do the circular pattern, we'll click the circle and then the axis. Okay. Psych. Where's the construction line? There it is. Okay. I guess I've like forgotten how to use this circular constraint. That worked that time. Yeah, I can't get this to work right now. My apologies. Sometimes CAD will do that. Just won't like work properly. Are there any more questions or like things that you wanted to see in Inventor?
Would it be are you comfortable with showing some of what you've done?
Yeah, I'm down to do that. Of course.
Yeah, just to show them what this program can really do, and like if you can do
For
the
sure.
yeah, thank you.
Yeah. Okay. So some of the projects I worked on this past couple weeks are, where is it? This one. So in Robojackets, I'm on a team called Robo Racing, and our whole competition is based off of autonomous racing. And so, a little broken. So basically, me and another one of my teammates was in charge of building this assembly that we call the steering assembly. So this whole thing is meant to be what drives our car. So it's a little broken right now because we were both editing it and I haven't re-uploaded it or gotten the newer parts, but I'll show you all what this final kind of everything put together looks like. Okay, let me go download everything real quick. or make sure I've already done that. Yeah. So this is our assembly of our entire car. Of course, it's not done yet, but it is kind of the outline of it all. These were all different parts and assemblies that were all created in separate files and then put together, all put together in this one area to kind of represent to us what our car should look like when we begin building it. Yeah, are there any questions about how we did certain things with this or how this can apply to FTC, FRC bots, or any specific questions about how we did kind of this assembly here?
I guess another quick thing we can explain is the bar on the left side of your screen, which had all of the different sub-assemblies. Do you like to explain how?
Yeah, I can go into that. Yeah, so this bar right here is, it'll basically tell you everything that's in your assembly. So all of these things right here were parts that we threw into this assembly. So if I can click anywhere and it will highlight the thing that just got highlighted in this lighter blue is what that is. You can also click on this little addition sign right next to it, and it'll tell you all of the constraints that you've used. So you can see that we've mated it to several different points. When you hover over that, it'll show you kind of like where it's mated and what it's mated to. And everything is kind of just like a storybook as to what your assembly looks like. These will also be in like part features. If I went right here, it's not a lot to look at, but this extrusion here is this entire part essentially. So you can click here and you can go back and see what the sketch looks like. If you'd like to edit it, you can just double click and can change how it looks, finish sketch, and then it'll automatically update. So this is just a really easy way to go back and look at where everything is in the CAD, what it's doing, and it's really helpful to kind of use this to debug your CAD if things end up breaking at some point. And then it's also, I'm using a mouse for this. It's really helpful to kind of get one if you want a CAD. I've tried CADing on a keypad on my laptop and it's not as fun or as easy. So definitely if you have mouses at your school, attach those to your computer and it'll make your life so much easier. Yeah.
if there are any more questions, we can end this session like 15 minutes early if you want.
Yeah, if there are any.
Yeah, why don't we give it till 4:30, I guess, to see if there are any additional questions that people have.
Would you like to show them what laptop you have, like the specs for it, as this individual was asking about what was good?
So for CADing software, you kind of always want like a 64-bit laptop. That's like the most I know. I have a Dell. I know it runs on Windows. I think for Inventor specifically, it'll only run on Windows, and you'll kind of want it to be like a 64-bit. Storage-wise, if you're using CAD, and the other panelists can correct me if I'm wrong, but you would like a laptop that can kind of store up to 256 gigabytes. If it can store more, that's fantastic. But when it comes to CADing, you'll need like at least a 64-bit Windows software. I don't know if that helps or answers the question in full, but
You can also Google Autodesk spec requirements, and it'll give you a quick list of different things such as disk space required, any sort of display resolution, memory, CPU type, that sort of thing. I've seen somebody run let me think. I've seen somebody run Autodesk Inventor on a Windows 7. I don't recommend that, but it does work. So mainly you just have to go on to the Autodesk website, take a look at the software, and it should give you all the answers that you would need.
What about would you like to also explain a little bit how like boot camp and how you can use MacBooks and load the flash another image on there and you
so
have to work on that. Work with that.
so I don't know much about how to run Inventor on a MacBook since it doesn't run on Windows. Michael or Alex, if you know, I know that I've seen people run Autodesk Inventor on MacBooks, but you have to like partition your disk space into like half of it's Apple, half of it's Windows. I can't speak much to that because I don't really know about it.
Yeah, to add to that, I also have never done boot camp. What I always did was remote desktop control of my PC when I had a Mac. So I have a Windows PC and I would just remote control it using T-Viewer. I did that for a while, but I've never actually just straight up done a boot camp to run it on Mac.
I
It's
cannot
definitely
speak to this
possible.
either.
Yeah.
I apologize for putting you guys on the spot there.
No, it's all
No,
fine.
you're good. There are definitely people out there who've done it. So you could, I am sure there are like YouTube videos or just tutorials on how to do it because I know a lot of people at Georgia Tech who do it. But
At
seems like
Robojackets, we also have a virtual machine, basically a virtual machine that we can log into. So no matter what our device is, we're able to access Inventor through that virtual machine, which works on Windows, Mac, and Linux. But beyond that, I can't really speak for how to get Windows software on a Mac. I haven't done too much with that before.
yeah. But it's a good question for sure. I'm sure you can find someone more knowledgeable than us to let you know how to do that.
Okay, do you want me to stop the recording now? Are you guys okay?
I think so.
No one else has questions. I'm good to